So today we're going to learn about equivalent fractions. And before we learn about how to create equivalent fractions or identify them, we should learn what an equivalent fraction is. So you see the definition there on the screen. It's fractions with different numerators and denominators that represent the same amount. So if we look at this example over here on the left, you see there's 1/2, and that's the same as how many sixths? Well, 1/6, 2/6, 3/6 is the same as a half. Over there on the right-hand side, you can see there's 6/6 representing a whole, or you could also say 5/5 representing a whole. It's the same amount, we're just using different numerators and denominators. And there in the middle, what would those fractions be? Count the one in yellow. 1, 2, 3, 4, 5, 6, 7, 8 pieces out of 10, and 4 pieces out of 5. So those are another pair of equivalent fractions. So here's an example of equivalent fractions. Marcus has 2/3 of a pie. You can see it there. He's got 2 pieces out of a total of 3. He wants to cut into smaller pieces, though, because thirds are way too large. You might want to eat a piece that big, but really, those are just way too big. So he wants to cut them into 12ths. So we want to figure out how many 12ths is the same thing, or our word equivalent. How many pieces are equivalent to 2 out of 3 pieces? So I could actually take these, I can make them smaller pieces. If I just break each of these in half, whoops, it's not going to turn out too evenly, but we'll clean it up here in a second. So in my very ugly drawing, okay, do I have 12ths? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I do have 12ths. Now, did I add any pie? No. Did I take away any pie? No, I didn't. I'm just calling them something different. I'm calling them 12ths. Here's an easier way to see that. I have much straighter lines here. And again, you're going to count. There are a total of 12 to make a whole. And how many 12ths do I have? Well, again, we can see there are 1 12th, 2 12ths, 3, 4, 5, 6, 7 12ths, 8 12ths that I have. 8 12ths. And you can see how 2/3 and 8 12ths represent the same amount. Different numerator, right? We have 2 compared to 8. Different denominators, 3 compared to 12, but those are equivalent fractions. We could do the same thing here with Michelle. She's got half a wall painted. You can see her 1/2 over here, but she'd rather calculate her progress in fourths. So how many fourths has Michelle painted? Well, I could turn these halves into fourths, right? If 1/2 is 1 part out of 2, our fourths would be a certain number out of 4. So again, with a quick sketch here, you can see now I now have fourths, and how many fourths are there? I'll clean it up a little bit with a neater copy here. I'm going to break these into fourths. How many fourths are there? Well, you can count. There's 1 of them. There's 2 of them. So we could make the statement that 1/2 is equivalent to how many fourths? Is equivalent to 2 fourths. It's the same amount of wall, whether it's over here or whether it's out of here. We're just naming it something different. And we can do the same thing here with Loretta in our last example. Loretta has 6/10 pan of brownies left. Must have been pretty good. She ate some. She's got 1, 2, 3, 4, 5, 6 out of 7, 8, 9, 10. So there are 6/10. We're going to shade this one a little bit differently. We're going to count her brownies. She'd rather count them in fifths. Okay, well, we could do that. If you actually look at the rows or the columns here that the brownies are in, it really looks to me like we could count these 2 brownies together into 1 row, and here's 2 rows, and here's 3 out of 4, 5 rows. So we could really take those tenths, and if we doubled those brownies up, we could say here is 1, here is 2 parts, here is 3 parts out of 4, 5 parts. So we could take our 6/10, and how many fifths would that be? I'll clean up the picture for us a little bit so we can see it a little bit better here. There it is in fifth. Now that's the same amount of brownies. She didn't add any brownies to the pan. In fact, I could draw a line right here, and I'm back to tenths again, aren't I? So 6/10 is the same as how many fifths? How many parts out of 5 parts? Well, it's the same as 3/5, or 3 out of 5 parts. So how can we check if 2 fractions are equivalent? We just drew it and we talked about them all, but you're not always going to have models. Models will help for today, but eventually they're going to go away. So how can we tell if 2/3 really is the same as 8 12ths? The picture looks okay, but again, the pictures won't always be there. Well, what did I do to 2 to make it 8? What did I do to 3 to make it 12? When we have equivalent fractions, we just do the same operation to the numerator as we do to our denominator. So let's see, 2 times what would give me 8? 2 times 4 gives me 8. So if I do that to the top, my numerator, I'm going to do the same thing to the bottom. I'm going to say 3 times 4 gives me 12. So notice we multiplied the numerator and the denominator by the same amount to write our equivalent fraction. Let's see if that works down here with our halves. Let's do a little bit of multiplication. 1 to 2. Well, I know it got bigger, so I'm going to use multiplication. All right, 1 times 2 is 2. Does that work on the bottom? 2 times 2 is 4. So again, whatever I did to the top, I do to the bottom, right? I'm going to multiply my numerator and my denominator by the same amount. But over here, I didn't multiply. When I went from Loretta's brownies, I said 6/10 is the same as 3/5. Well, 6 actually got smaller when it became 3, so it wasn't multiplication. What was it? It was division. What did I divide by? 6 divided by something gives me 3. 6 divided by 2 gives me 3. Does that same operation work on the bottom? 10 divided by 2 gives me 5. It works. So even if we're dividing or we're multiplying, as long as we do the same thing to the numerator as we do to the denominator, that gives us an equivalent fraction. And here's our last slide. What other equivalent fractions could we make? We could say, take that 2/3 of a pie and let's make it 12. So maybe say, well, now maybe my pieces are too skinny. I want some to meet sort of in the middle here. Well, we could actually make it 6. Now we could try to shade. We could say, well, I think about this much. Yeah, that looks about the same, but we're not always going to have models in front of us. We want to be able to do it without models also. Well, let's think about this. If I'm going to go from 2/3 and I want to make it a number of 6, use our multiplication or division. 3 times what is 6? Well, 3 times 2 is 6. So 2 times, what am I going to multiply by? 2 times 2 would be 4. And let's see if 4 6 actually works. Hey, look at that. It's the same amount of pi, 1, 2, 3, 4 out of 6. It works. How about down here? When we check out this one, our wall here, we could say 1/2 is the same as 2/4. But what if she wanted to break it into eighths? What would that equivalent fraction be out of eighths? Well, let's see what we multiply or divide by. We're going to take 1/2. How would I turn halves into eighths? Well, 2 times 4 gave me 8. So 1 times 4 is going to give me 4. So we think 4/8. And sure enough, when we take a look at our model, is 4/8 equivalent to a half? It is. 1/2, 2/4, 4/8, all those are equivalent fractions. And our last one with our brownies, we said Loretta could say 6/10 of the pan is left, or she could say 3/5. But what if she wanted really skinny brownies? She's going to have a party and she wants a lot of people to have brownies. Well, we could do the same thing here one last time. We're going to say, instead of calling it 6/10, if we're going to make it an amount of 20ths, how to get from 10 to 20? Well, 10 times 2 gives me 20. And 6 times 2 is going to give me how much? That's going to give me 12 20ths. So we would say 12 20ths should be equivalent to 3/5 or to 6/10. Let's see. There's amount of 20ths. You can count them and see 4, 5, 6, 7, 8, 9, 10. Another row of 10 is 20. Let's see, do I have 12 of them? There's 6 up there. There's 6 down there. That's 12 out of a total of 20 pieces. So equivalent fractions are fractions that have different numerators and denominators, but represent the same amount. Here's one more example for you without a picture. Can you do it?